All right, so in your past, I feel like you have used degrees for a ton of stuff when you're dealing with angles. And in calculus, we're basically going to say goodbye to degrees and hello to grown-up math. And so we're going to use the grown-up way of measuring an angle, which is a radian. So the first question is, a lot of times, how do you convert degrees to radians? Right? So pi radians is the same as 180 degrees. And I think the important thing is some of you are going to think about the fact that you know all the way around the circle, right, is 2 pi. And so you could say 2 pi radians is the same thing as 360 degrees if you prefer. Okay, but since I could divide both sides of this equation by 2 and get this one, this is the one I typically use, right? So if you have a degree measure, what you can do is multiply it by pi over 180 to convert it into radians. Okay, and the reason why it's pi over 180 is since these things represent the same quantity, this is really like multiplying by a big 1. Okay, because pi radians is equivalent to 180 degrees. Okay, now how do you remember which one goes on top? You can think about unit cancellation like in science, right? If you struggle to remember which goes on the top of the conversion fraction. So if I say 150 degrees, I'm interested in what that looks like in radians. I know whatever I multiply by, since this is 150 over 1, right, my degrees are going to have to cancel, which means the degrees have to be in the bottom. So I'm going to have 180 degrees so that I can get the degrees part to cancel. And what I know is equivalent to 180 degrees is pi radians. And so if I think about that unit cancellation, then this will be my remaining unit, which will leave me with radians, right? So 150 pi over 180 radians. Now, no one's going to leave it like that, right? Couple of things, make your life easy. Get rid of those zeros, and then what goes into both 15 and 8. You can do it in one step, you can do it in a couple, right? If you think like, 3 goes into both. So I'm talking about 5 pi over 6. Okay. And so that would be the radians that is the same as 150 degrees. All right, now it's really important, right? Calculus is grown-up math, it uses radians. You're going to need to be comfortable working and thinking in radians. It's kind of like when you are starting a new foreign language, right? You know that you really understand that foreign language if you have a dream in it, or you can kind of think in, say, Spanish, as opposed to trying to translate all the time to that other language. And so I really want you to start thinking about angles as radians as opposed to thinking about it in degrees and then translating to radians, because that's just a lot more mental load. Okay, all right, so this is the next question for unit circle. Which angles should you know? Okay, so I'm going to go through that with you. You should definitely know the angle 0. Okay, and we talked about how halfway around the circle is pi radians. And so the first thing I do to think about angles I should know is divide this top half of the circle into fourths. Okay, so that means in the first quadrant I'm going to go halfway, approximately, and that would have to be pi over 4, because if I'm dividing the top half into fourths, right, that would be 1 pi over 4. Okay, if I go up to the top here, well, that's 2 pi over 4, because it's 2 fourths, right? We're going to write it as pi over 2, just from simplifying. Okay, halfway in the next quadrant, right, that would be 3 pi over 4. And here would be 4 pi over 4, right, which we will write as pi. And then I can keep going and counting by pi over 4. So now I'm going to divide the bottom into fourths, right? So this is another fourth, so 5 pi over 4. Down here then, 6 pi over 4, which when we reduce, we get 3 pi over 2. Okay. And then halfway, last one, right, 7 pi over 4. And then that takes us back up to here, which would be 8 pi over 4, which is the same thing as 2 pi. So it helps you to think about that. So those are some of the really important ones. Okay, they're not the only ones, but those are definitely ones that we expect you to know. In addition to that, after you count around there, also counting by pi over 6s are other important ones. Okay, so I'm going to show you what that looks like. If I want to count by pi over 6s, that means going from the starting here to pi, I need to divide that up into 6 equal pieces, right? And so if this is going to be halfway, I'm going to end up dividing each quadrant into thirds. So this is going to be pi over 6. Up here, 2 pi over 6, which is the same thing as pi over 3. Okay. Here we talked about how this is 2 pi over 4, which is pi over 2. It is also 3 pi over 6, which is pi over 2. Okay, 4 pi over 6, which is 2 pi over 3. That's maybe a little low. And then this would be 5 pi over 6. And then you get down here, which would be 6 pi over 6. Again, we're going to call that pi. Keep going with your thirds. 7 pi over 6 down here. 8 pi over 6, which we would call 4 pi over 3. Right? Down here, 9 pi over 6, which is the same thing as 3 pi over 2. 10 pi over 6, which is the same thing as 5 pi over 3. Okay, and then finally 11 pi over 6, and up here 12 pi over 6, which again would be the 2 pi, right? So if you go around and you count by pi over 4s, so splitting the top half into fourths, right? And then you go back and you split the top half into sixths, counting by pi over 6s and reducing as you go. These are all of the angles that we would require you to know, okay? What happens if I give you an angle over 2 pi? Okay, so for instance, let's say I say, all right, let's talk about the angle 17 pi over 4. Okay, well that is not on the list of angles that I told you to know. So does that mean that you just can't answer the question? No, right? It means that we need to think about what this is actually saying, right? So if I go all the way around the circle, I'm at 8 pi over 4. Okay, and then basically I start again, right? And so I'm going to just subtract off 8 pi over 4 because that basically puts me in the same starting spot as I would anyway, right? And so this would be 9 pi over 4. Okay, so these two are exactly the same angle. All right, well 9 pi over 4 is still bigger than my 8 pi over 4. And so if I subtract off 8 pi over 4 again, right, I'm saying I just went all the way around the circle. I'm at the same starting point. Then I'm at 1 pi over 4. Okay, so that means this and this are exactly the same place, and 1 pi over 4 is on my circle. It's right here. So if you want to know what the angle is at 17 pi over 4, it's just that you've gone around the circle twice, and then you are going an additional pi over 4. So that's how you would deal with anything larger than 2 pi.